Okay, so this is problem 2 on page on 399, and we're doing the shell method here. So it's got we've got this equation. Oh no! Oh wait, maybe. Okay, cool. It says integrate from 0 to 8. And, and it is nice drawing the point x, y just to show like, okay, that's there's your y value, there's your x value. These are going to be horizontal slices, okay? And you're rotating around the x-axis, So I'm going to draw that on there to show the rotation, and then it's going to make some shell kind of like that. I'm not very good at drawing these things, so you have to visualize it. So just like before, imagine if we took that and we laid it out flat. You would just have this prism with the width of it's going to be dy. So let's just talk about the volume of this one slice. It's going to be dy, and then the circumference, which we said is 2 pi r, okay, and then times the height. Sorry, we got a video here. Okay. And then let's see. So that's the circumference, and then we need the height right here. And I'll just say height. Okay. All right. So let's see. Look at your picture here. The radius. Here's the radius right here of the shell. So that is your y value. So that's not so bad. So 2 pi y. I got dy still. And then the height. So that's going to be this distance right here. It's so helpful to draw this out. I find it just very, very helpful. So what is this length at any point? So like, let's see, if I took this point, or like right here, these are all the heights of each shell. Well, what do they all have in common? They're all going from 8. They're all going from 8, and then they're subtracting this distance right here, which is this x. So at any given moment, it's this length minus this distance, which is the x value. So I'm going to put that 8 minus x. Okay, so that's the integral we're going to use. Integral from 0 to 8, 2 pi y, 8 minus x. dy. Okay, problem here, I have an x, and that's no good because I'm integrating with y. These are horizontal slices. So let's back up. What was the equation from the, let's see, y equals, that was the equation given earlier. So I need to get x by itself so I can plug in a y. So let's see, if I put this to the 3/2, that cancels that out. So y to the 3/2 equals x. Okay, that's not so bad. Let's go ahead and do some of these things then. Okay, scroll up here. Great. 0 to 8. Oh, I'm sorry. Wait. 8. That's not a y value. That's an x value. So I'm not integrating to 0 to 8. Look back at the picture. Say I'm integrating this way. So imagine doing all of these slices right here. So what is that value at the top right there? So I think it's 2, but I'm going to graph. I'm just going to graph here. So I'm going to graph the equation y equals x to the 2/3. Yep. And I'm going to look at when x equals 8. What point is that? No, it's 4. That's the value of 4. So this intersection point, when x is, oh, no, come on. There we go. When x is 8, y is 4. So that's where I'm integrating from, right here. From 0 to 4. Okay, and that's in the y's. 2 pi, we can pull that out front. Y, we'll just leave it there. Now 8 minus x, but 8 minus, instead of x, I'm going to put y to the 3/2. dy. Okay, now it's looking a little better here. So let's see, 2 pi, 0 to 4. I'm going to distribute this y. So 8y minus y to the, now think, this is y to the 2 over 2. Oh dear. times y to the 3 over 2. And you're going to add exponents, right? So that becomes 5 halves. Okay, cool. dy. All right, there's our integration. Let's use the fundamental theorem of calculus. And we got 2 pi. This is going to become, what, 4y squared? Is that right? 4y squared. Check that real quick. 2 times 4 is 8. And yep, good. Minus, okay, and this is going to go up to y to the 7 halves. And then this will be 2 sevenths. And check that real quick. 7 halves times 2 sevenths. That's 1. 7 halves minus 1 goes down to 5 halves. Cool. And then we're going to integrate from 4 to 0. Now notice how I put these parentheses here, because it's all of that comes out of the fundamental theorem of calculus times 2 pi. So let's see what happens here. Let's get my calculator over here. Let's see, that becomes 4 times 16 minus 2 sevenths. 4 to the 7 halves. What is 4 to the 7 halves? 4 to the 7 halves. It's 128. Okay. So 128 times 2 sevenths is a nasty fraction, of course. Okay, well, then I'm just going to type all this in and see what I get as a decimal then. So I get 2 pi. And then I know that when I plug in 0, it's all going to go to 0, so that's fine. So 2 pi times 4, 16, minus 2 sevenths. I'm typing in the calculator exactly like it looks here. To the 7 halves. All right, I got this answer 172.338. I'll put units cubed. I don't think I have a unit on this, do I? Nope. And there we go. That's our solution.